Welcome to Natural Habitat Adventures, Daily Dose of Nature. Today's topic is Meet the Flipper Feet, Pinnipeds of the Arctic, Part 1. And our presenter today is Kristina Disney, one of our NatHab expedition leaders. Thank you so much for being here today, Kristin. I'll turn it right over to you.
My pleasure. Thank you, Sunny. Hi, everyone. My name is Kristina. I've been an expedition leader with NatHab since 2018, I think we're going on. And yeah, I mostly work up in Churchill, and so I definitely love to spend any other time I can focusing on some other Arctic animals, which brings me to the inspiration of this presentation, of this webinar. I remember being a kid and, starting to learn about evolution and things like that, and being so astounded when we learned about marine mammals, and the idea being that these animals evolved from the ocean, learned on land, and then all of a sudden backpedaled and was like, whoa, 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 hang on a second. We want to go back to living in the ocean. And so after developing all of these abilities in order to survive on land, lungs, mammalian features, they now have readapted those to once again survive in the water. And so specifically when we think about pinnipeds, things like seals, walruses, sea lions, they're amphibious, right? And so being amphibious means they have to have dual purpose adaptations, which leads to very fascinating builds. And so the focus here, we're going to focus on Arctic, we're going to focus on the pinnipeds. And often when we think about the Arctic, this isn't the view that comes to mind. I don't know if you've noticed there in the bottom left corner our scuba divers. So this is a view of polar ice from beneath. This is what the world looks like if you're a pinniped and living in the Arctic. If you're a fish, right? When we as humans think of the Arctic, we tend to think of this view, a very lonely, desolate place, right? But or maybe if you don't think about the Arctic very much at all, this might be the thought that comes to mind. It's simply an empty wasteland. But in fact, the wealth of the Arctic isn't on the surface. The wealth of the Arctic is underneath. So Arctic waters are some of the most biologically highly productive waters on the entire globe. They're phenomenal. They have high oxygen content, there's cold water, high nutrients from the Arctic upwelling. So if you think about all these nutrients sinking in the ocean, and those nutrients, the ones that have gone very deep down, they come back up at our poles, both the Antarctic and the Arctic. So even though we tend to think of these places as not biologically productive, they're actually immensely productive with huge amounts of growth happening there, which is why so many animals think about migration, right? That's why so many animals make the trek north and south, because it's worth it for the amount of energy that's possible for them to consume there. So we're going to hone in on those Arctic mammals. Now, if you're an Arctic mammal living there on the sea ice, you have a very delicate balance you need to maintain. They need to keep regular access to oxygen. So think about our cetaceans, think about the whales, the pinnipeds, right? They have to come to the surface to breathe, but they're living somewhere which is essentially has a sealed layer on top. So they have to always be keeping track of that and finding air holes. But simultaneously, their food source is deep in the ocean. So they have to always be balancing where they're going to get their next breath from and where they're going to get their next meal from. Pinnipeds, to add to that balancing act, have the classic, your greatest strength is your greatest weakness. So pinnipeds have evolved to feed and spend most of their time in the water, but they have to come onto either land or ice in order to give birth. Many species, there's a couple species that can nurse in the water, but most species need to nurse on land or on pack ice. And then some species, well, most species actually, need to be on land to molt. So essentially, molting in this case, don't think about it like an insect, same sort of concept, but they're shedding their hair and in some cases a layer of their skin as well. And so there are exceptions, but the vast majority of pinniped species need to be able to be on land to do those processes for their life cycle. Now, or they need to be on a substrate, I guess, right? So if you're an Arctic seal, that generally means that you need to be on ice. So let's factor in the complications here. They need to be able to breathe. They need to be able to get food. They need to be able to go on to the sea ice to nurse. Now let's think about the conditions of that sea ice itself. So sea ice is continually in a thaw and freezing cycle. It is quite treacherous. It's always moving, it's adrift, it's forming and reforming. And so really, this is a very, very complicated environment to survive in. And then also when we think about sea ice, if you think about what we call multi-year ice, so imagine that glacial cap, right? So that center of the ice tends to stay, and that's actually quite unproductive in the very middle, because there's nothing that can get oxygen there, or you're just a fish swimming underneath. But if you're a mammal, that's not a great place to live. So they like to congregate around the edges, around the cracks, or we call them, we'll say like terra infirma is sort of a nickname, or not a nickname, that's maybe too informal of me, my apologies. Right, the idea that it's always changing, right? We think about infirma, being sick, being weak, but the ice is always shifting. And so that's where they've essentially found their niche of survival. And so I want you to keep in mind throughout this whole presentation that pinnipeds, Arctic pinnipeds, have an obligatory relationship to that sea ice. They really can't survive without it, because that's what keeps them close to their food, but also allows them to haul out and continue their life cycle. Now, if we think about how they got into this predicament or this balancing act, evolution is always messy. I like to think about it as when someone asks me for a recipe for something that I've made. I really love to cook, but I'm not terribly great at following instructions. And so someone will ask me and I'm like, well, it was a little bit of this and this, and I think I did this at this point. And I tend to think of evolution like that, because no one truly agrees on how we got there. They know that this one split off on this branch and this one split off here, but essentially we can all agree that there's a fossil record that shows that pinnipeds have been around for about 27 to 25 million years ago. And so that's how we have these three general groups. You have the Phocidae, the Otoridae, and the Adobabenidae. So we've got true seals, which essentially means they're earless, right? So you and I, when we look at our ears, we have, you can actually see our ears, right? But when you look at the true seals, there is a gap there, but there's no external pinnae. Whereas eared seals, they've got the big ears, their pelvises are different, they can actually walk. So, you know, if you think about someone doing the worm, when they're doing the dance move, the worm, that's what Phocidae have to do, because they don't have the same sense of movement on their pelvis. So for Phocidae, their pelvis is fused to their spine. For Otoridae, excuse me, their pelvis can actually move separately. So they can do a bit more of a walk, and they can actually be pretty quick. It's funny to watch, but they can be pretty quick. So you don't want to end up getting stampeded by our friends there. And of course, the walrus is hanging out in a class of its own there. Certainly worth the attention. And so today, as you've noticed, we're talking about part one. So today I'm going to talk about some general characteristics that are carried through pretty much all pinnipeds, specifically the Arctic ones. And then next time, if you come back and join me on the 21st, we're going to go into each species specifically and talk about some amazing traits that each one of them have, some conservation efforts with them, some stories behind them. But for now, we're going to lay some very solid groundwork. And I think the best way to start with that is actually talking about fitness. So in the human realm of fitness, you know, we think about going to the gym. We think about, you know, these lean, mean muscle masses and what you can do. But in the animal world, fitness has a much different concept. And I think it's really important that we ground ourselves in the ecological definition of fitness before delving into all these adaptations, because I think it's a much better way to understand where they're coming from. So if we look at my lovely ballooned friend here, this is a very, very healthy, very happy seal. And so when we think about life cycles, we're thinking about the balancing of resources, right? And this one here has definitely piled on some excellent blubber resources. So specifically the Arctic, this is a general rule of thumb, mammals are very large bodied. The idea being that you invest in a high amount of tissue growth, you invest in the ability to, like, surface area staying warm. And so the general, what we call the fitness or the health of the population is held in the adults, right? So they're investing in their young as well, but they're not investing in, you know, they're not like ants where they're having a whole bunch of little eggs and the eggs will carry on. And if some of the ants perish, the colony survives, right? Seals are much like us. They invest in a one or two, well, in a single offspring. Usually twins are very, very rare in seals. And so all the effort goes into seeing that one offspring succeed. And another really cool thing about them is that they are precocial. So essentially that means that when they're born, they're highly cognitive. In some species, they're able to swim within hours. So right, think about a baby calf being born, they can stand and suck right away. Same with seals, they're up and on their feet right away, and or up on their flippers right away. And it's a predator response, right? They don't have time, they don't have the luxury for these things. So the ones that were able to get moving faster, those are the offspring that survived, selections carrying forward. And so this is one of my favorite things, is that true fitness ecologically is measured by grandchildren, right? So if you were to measure the health of a population and the fitness of a population, you would measure it of an individual's successful grandchildren. And so for me, that really kind of drives home. It's a very big concept right now, the idea of the 7 generations forward, right? Making decisions that will benefit not just yourself, or maybe even necessarily might not be that good for yourself, but if they can hold yourself together in order to carry forward for your children, your children's children, and so on and so forth, I think is such a great sentiment that we can definitely re-adopt. And so, starting off now with our more specific adaptations as to where everything always comes back to is reproduction. And forgive me, but I'm gonna throw some seal puns in throughout the day because I simply could not help myself. So when we think about seals, sea lions, walruses, etc., we can essentially split them into 2 general categories and strategies. So we can think about them as land breeding or aquatic breeding. So when we think about land breeding, I think that's the image that for a lot of us comes to mind. You know, these huge populations all gathering around on the beaches together, you know, big dog piles sleeping in the sun. And so essentially in those scenarios, what is happening is that the resource that's limited is a good place to haul out. And so that means why all the females will aggregate and the males will go there to compete for them. Now, in a different version, when you have aquatic breeding, the resource limiting isn't the haul out space, right? They're looking for air holes, so they're more dispersed. And so because the females don't aggregate, then the male's behavior has to change to reflect that. So here's an example. Here's one example, right? So you have the dominant male in the center, then there's a beta male, and then the peripheral males. And so periodically, the peripheral males will often challenge the lead male, the alpha male, for its position, and sort of you think about it as like breeding access. And because that, I'll come to this later, but those males are often actually fasting. And so even though they might be the biggest and strongest for a little while, they will eventually tire because they haven't had a chance to go and eat in sometimes weeks, sometimes months. And so when that happens, they get tired, they will eventually lose their spot at the top in that competition, and then the other males will cycle through. So that's why you might think it's strange. Why would they just lay around on the sides waiting? But they've gone, they've eaten more recently, and they're waiting in order to compete and win that spot. So this is when you have big groups. But another version is that what males will do is they will sequentially defend one female at a time. So this is a land breeding example I have a picture of, but let's think about that aquatic example. So imagine you're swimming around, you find a female, you're like, sweet, you're gonna stay with that female until she is ready to breed. And then, so that's essentially they're defending that specific female. And then once she's bred, then they'll move on and look for another female, but they'll stay with that one for as long time. And then another thing that will happen is that males will congregate. It's called lekking. So the idea being that they will do displays. So there'll be like sort of a communal area where everyone's hanging out at. This is more like the, the peacocking, right? So they'll all hang out in the same spot. The males will do their swimming displays, and then the females will pick based on that. So each of these reflects the resources available to the species in the region that they're living in. And I just want to circle back to that thought that all reproduction relies on that ability to haul out, right? So in order for these cute little babies here, and this one's actually having a hard time if you notice, so the pup here isn't on solid ice, right? It's fallen, or maybe chose it to, but it doesn't really want to be there. It wants to be up on a solid chunk of ice because it's taking a lot of body heat to stay warm in that slush. So coming back to reproduction, right? So birth, lactation, all of that needs to happen on a solid substrate. And they're going to time that with, they're going to time their birth cycle with the resources for food, right? So when we think about marine mammals living in the Arctic, right? There's a very big spike. We've got, the sun's gone for near pitch darkness in the wintertime, so there's not a whole lot of primary production, right? You don't have a lot of algae producing things, so there's just not a lot of food available in general. But then you're going to get those full daylight summers, and so that's going to kick off a huge phytoplankton bloom. And then you can think about that like a domino effect. First comes the phytoplankton, then you get the zooplankton and the krill, and then the small fish and the larger fish, right? And you're following that food chain upwards. And when that happens, the seals try to time their birth at the same time. Whereas if you think about animals that live at the equator, they don't have to be nearly so synchronized, right? Their food levels are essentially the same all year round. There are some exceptions to seasonal variances and things, right? But so for example, like harbor seals all are going to pup very, very early in the spring, all within a few weeks to a month of each other. But monk seals that live on Hawaii, their pupping can range in a whole 6-month period. It can be any time, right? They're not all having them in the same time because they don't have to have that same pressure. So another really cool thing about their reproduction is that they can do something called delayed implantation, which I think is so insanely cool. And I'm not gonna lie, I wish humans had evolved this way too. So what that means by delayed implantation is that the male and female will mate, but then the embryo will actually pause in a certain stage of development and will wait before it implants into the uterine wall, so that the female can give birth at the most opportune moment. There are also times when if the body health conditions aren't enough, they will actually abort and slough off the embryo because they don't have enough of their own body health in order to maintain it. And so they will wait until the next year in order to give birth. And so that's the same time. And then the other thing to keep in mind is that the weaning period, so the mom is going to stay with that pup until weaning happens. And essentially weaning for a seal is they're feeding them, they're coming on land to nurse, and then at some point they decide that they've got enough, they've reached a certain health level, and mom goes off and she swims off, and the pup is left on land to molt for them, to sort of fend for themselves. They're essentially fast. They have to molt their little, their coat that they're birthed with before they can essentially go live in the water. So it's a very vulnerable time. And this is not an Arctic pinniped. This is actually a gray seal from the Isle of May, but I just wanted to sort of visualize what that nursing looks like, right? So they're really tucking in next to mom. And I don't know what type of dairy everyone here likes to drink, or maybe you're not consuming dairy products these days, but if you were to drink seal milk, it is as full fat as you can get. So depending on the species, their fat content of their nursing milk is anywhere between 47 and 61% fat. And this is phenomenal if you're a seal pup, because it means that your weight gains are incredibly high, right? They're trying to get them to be as chunky as possible so that they can get them in the water as soon as possible, right? That's the purpose of this. And so depending on the species, their weight gains can be anywhere from kilometer, a kilogram, 1.4, depending on the species on the lower side, all the way up to 7 kilograms. So think about that. You could gain, if you were a seal pup, on a lean day, depending on your species, you're gaining 3 pounds in a day by how much you're nursing from your mother, or some of the larger species are gaining up to like 18, sometimes 20 pounds when you think about that, pretty close to 20, which is a wild, wild weight gain. So those are the ones that are gaining that much, they would probably only be nursing for max a week, and then mom would wean them. Whereas the ones that are gaining, let's say those 2-3 pounds a day, those ones might be nursing for a few weeks, and then mom will wean them after that once they get to a healthy body weight. Now, I think that this is a good thing to remember when we think about this. So for every action, there's an equal and opposite reaction, right? And so think about that. Those pups are gaining an obscene amount of weight at a very rapid rate. And where is that energy coming from? Where is that weight coming from? It's coming from mom, right? And what's even more impressive is that these females are often fasting. So they're not even consuming anything while they're giving up so much of their resources to their pups. Depending on the species, some of them can go up to 2 months without eating and still produce that high nutrient-rich milk for their pups. And it's not just the females that fast, right? So when I mentioned before about the males, sorry, excuse me, this is falling. There we go. So it's not just the females that are fasting, right? So those males, when they're trying to breed, they will also they will fast for a very, very long time, sometimes up to 2-3 months. Some like walruses can go for that long. Smaller ones, they'll tend to have a faster turnover rate. And so when you're fasting that long, essentially the game plan, whether you're the female or the male, is you eat as much and bulk up as much as you can, because you're going to lose a huge amount of your body weight, right? So their reserves, when you think about it, they're losing between 35 to 50% of their body weight. So imagine you and I fluctuating half your body weight every year. It's an insane amount that their body goes through and turns over. But it's largely due because they have that very, very high fat diet. And we're going to take a quick plunge into molecular bio. I promise not to make it too sticky. I just think this is really cool and it's worth the time. And to be completely honest, I was terrible at genetics and molecular biology. I barely survived that. I was always better at the ecology. But there's just cool things that I think are worth the minute. So when we think about these species fasting and you think about their metabolism, right? They slow down their metabolic rate as they're not eating for days after days, right? So think about, not conscious necessarily, but almost think about if you could tell your hair to grow slower and you could tell your body to slow down, and everything just becomes to a slower pace, right? So they can conserve this energy for these really long time. And so they know that over time, what this graph is showing you, right? So those 3 to 6, the first few days of fasting, this is their waste, right? And as the time goes by, they waste less and less nitrogen compounds. And so for you and I, why that's important is nitrogen is what makes up protein, right? And so when we talk about them having these crazy weight swings, they're conserving their protein, they're consuming all their micronutrients very, very efficiently. And what they're gaining and losing is fats, right? So their systems are very much dialed in so that they don't have to waste any of the nutrients that are hard to get in that time, but their fat is going to have a huge drop. So now I've talked about when they're not eating, but let's think about what do they actually get to eat when they do eat. So depending on what species they are and where they live, you're going to find different seals, etc., to be either generalists or specialists, right? So think about your generalists. I'm not going to use the word scavenger, right? But they've learned to hunt several different things, right? They take advantage of their opportunists. They'll eat whatever's around, doesn't necessarily have to be the highest caliber of quality. And then you have specialists who live in specific zones. Maybe there's a really high abundance of crustaceans and they get really good at hunting crustaceans, and that's their thing, right? Some of them in the Atlantic are really going to focus on cod. Another thing to keep in mind is that, so what they eat actually changes as they age. And this kind of makes sense. You know, if you think about us being teenagers, we don't always necessarily you're gangly, you're awkward. Think about playing a sport, right? It takes a while to figure things out. So when they're younger, they'll often go for food that is maybe not the most high energy, but it's easy to get. And so they'll eat a lot of it. Whereas when they get older and more practiced, they will focus on higher energy prey. So the benefit to energy output, excuse me, is more worthwhile, right? And so it's a good thing to remember. So you'll have, even within one species, they'll have their own preferences of what they're eating. Diving. We're going to talk about some diving adaptations, which are so fantastic. I think I actually went swimming. I have a friend of mine who does free diving, and she took me out with her, and I could only hold my breath for a minute, which I thought was not terrible, but they're able to hold their minutes for 3 minutes, 5 minutes. It's fantastic to see what they can dive. But we, however, still pale very much so in comparison to a seal's ability to dive. So thinking about their diving process, they actually exhale before they go down, and it's part of a way for their body to equilibrate. And they're also able to slow down their heart rate very, very, very slow. So they can get their heart rate down to 15 beats per minute, right? So trying to conserve as much that as possible. Another thing to keep in mind is that marine mammals in general, not just pinnipeds, have way more blood in their body per an animal with the same weight class, right? So if you were to compare a seal, to a deer or something like that, if they were to be the same weight, there would be a greater volume of blood in the seal than there would be in the deer. And that's because they need to get that oxygen flowing throughout as much of their body as possible. And they have a higher degree of hemoglobin too, right? So hemoglobin is the part of your blood that's carrying that oxygen with it. It's the delivery truck. And what's also really cool is they did a study and they found out there's a special type of, it's not hemoglobin because it's not for blood, but there's a special type of globin that goes to the brain. And so they have a higher amount of that makes sure that all of their systems keep functioning, which I think is so, so cool. And another thing to keep in mind, which I actually work also as a kayak guide, and I just finished this last weekend, one of my last trips, and we got to see some seals, which was so great because I was just coming to do this presentation, and so I was like, yay, reminding me of some things I wanted to add in. And so when you do see a seal at the surface, what they're actually doing when they're catching their breath, so it takes them, for whatever time they dove for, they need to spend twice as much time above the air or above the water to catch their breath. So if you sit there and you watch a seal come up and you check your watch and you see how long it's up for, divide that by 2, that's how long it was just underwater, which is a fun thing to do, I think, with guests, is to see how long they're diving for. Now, the purpose of those dives is for food, right? And so even though they're capable, some species like the ring seal is capable for going down for 30 minutes, but that's not their average dive, right? They would much more prefer to do short series of dives and do lots of them quickly. So we call those dive bouts. They're going down and they're trying to get some quick food, come back up, and just keep doing that cycle as often as possible, right? And so the trade-off, depending on where they are, is the prey to dive ratio, right? So if they can go down and get a few prey quickly, that's less energy than having to go down, right? So if they're going to go dive deep, they want to be getting something that's a good payoff, right? That balance of time to work effort. And then again, thinking about sort of food preferences, another thing to think about, sort of tying it together, is that so larger bodies, right? If remember talking about this, so if you're a larger body mammal, it means you have more blood, more oxygen in your blood, so that you can actually dive longer. And so one thing that we see in a few different species is that males actually tend to eat different foods than females. And part of the reason we think this kicks in is because males sometimes they have dimorphism, so they'll have if they do have a bigger body size than the female, then they can hold their breath longer, dive deeper, and actually look for different prey. And so it puts them in a different food class, which is sort of important then later on when you think about, females and males both needing to bulk up. They're not competing for resources. So it's it's a 2 birds with 1 stone solution of nature of how to divide up who's eating what. Another thing that I like to think about, so when we talk about all these cool things that we've learned, I think something that's really important to take a step back and look at is, how do we know what we know, and how do we know what we don't know? And I was jokingly called that's what science is, right? So, and I think it's really cool to share some of the experiments of how we've figured out these things about different species. So one of the ways that we've learned about their foraging behavior and their diving is that what they actually, there's Antarctic fur seals that these researchers put drag weights on. So think about when you are in an airplane, right? You've got the engine pushing you forward, you've got friction pulling you back, you've got gravity pulling you down, and you've got lift under the wings, right? This lifting you up. And so they actually put drag weights so that the females were less efficient on them, and they were seeing their behavior change. And the females that had the weights attached to them made shorter, closer dives because they couldn't be as efficient, whereas the females who didn't went further away. And so you can see, I mean, we manipulated that scenario, humans did, right? But it's a way to understand their behavior and their choice of logic of what they're using for food sources. Another way that we understand where they've been, and also one of the things that we're starting to understand of how little we truly know, is telemetry. And I cannot get over how funny the one on the cap is. This picture never stops making me happy. And so the goal of these is to be able to long-term track where pinnipeds are going, because right now and historically, we pretty much only understand their distribution based off of their breeding sites. So where they're hauling out on ice or on land, that's where we're getting our population counts from. That's where we're determining their home regions. But we've actually learned recently with different telemetry studies how that is such an underestimation. There was one, I think it's a Pacific elephant seal they did a study on, and they put a tracker on it in Baja California, which was its home range, which we've always considered these elephant seals home range, and found out with this tracker that it covered huge tracts of Pacific North. It went up all the way to Alaska, circled back around. It covered an amazing amount of ground, or water, excuse me. And so we're learning that just because the breeding sites are not a very good way for us to actually classify their home regions and their distributions and the populations, right? And so in case some of you are wondering, the way these are designed in general, right? So we know that pinnipeds molt. And so they are going to be stuck to them for, depending on the time of year you put them on, right? But annually, because they molt, these will come off when their hair sheds. So it's not a permanent attachment. Most of them, they're getting better and better at the efficiency of them. And so, yeah, they're very cool studies. It's one of the most complicated things when studying and tracking marine mammals is how to track them. In the old days, some of the sensors they used to put on whales were quite brutal, if I'm gonna be frank. I remember learning about those a few years ago and when I was still in school. And so we've come a long way, right? We're trying to inhibit them as least as possible, but still try to understand more, right? So the inefficiency of having a strange hat for a few months has huge benefits in what we can understand about seals, especially when we're making decisions, things about like Arctic shipping lanes, right? So you always have to remember the sake of science when you take a step back of the bigger picture, right? And the benefits that can come from it. And the cute ability for us to see that cute little hat. And so, because we can thank these marine biologists who have spent all these time studying, we've learned so many amazingly cool adaptations that pinnipeds have developed throughout their evolution. And one of my absolute favorites is actually their whiskers, or their vibrissae. So when you think about their whiskers, they actually have an amazing amount of information that they collect with them. This is one of the benefits to being a land mammal and then returning to water. So to put this in context, a cat, so we have in their whiskers, right? They have nerve endings attached and they can feel things. And think about how aware your cat is. So they have somewhere around 200 nerve endings in their whiskers. If you are a harbor seal, you have 1,500. They have amazingly adept whiskers for feeling things. And what we've actually learned is that their whiskers are so fine-tuned that they can feel the whirl, the swirls and eddies left behind by fish that have just passed through. And so the way that they can do this, the reason why they're so fine-tuned is actually because of the shape of their whiskers. So think about like the antenna on your car, right? When it gets really windy, it kind of starts to shake and shudder and it vibrates. And so that vibration would actually cancel out the really fine details that the seal is trying to find. And so their whiskers are oval shaped. Even their whiskers are streamlined, so they don't vibrate very much. And so that way they can pick up the vibrations of the water left behind ahead of them. And one study showed that they were able to tell the direction, the size, and the approximate size of a fish 30 seconds after it had swam by, which I think is so, so cool. The other thing to keep in mind, right? So we're mammals too, right? And so think about how mammalian skeletons have evolved, right? And then think about, you know, our skeleton has evolved a certain way, and then we go back as humans and we try and recreate that, right? So think about flippers, think about the shapes that we use. We're mimicking the way that seals have evolved to move through the water, in essence. And right, and so where our bones are fused in some places, theirs are not, and vice versa. And so you have different expressions. And that's again what I was talking about of so the Phocidae, their pelvis is fused to their spine, which allows them to have that mermaid more like swim, right? And they do have 4 flippers, but the back 2 tend to work as a single unit, right? They're not split apart. Well, they are if you're a sea lion. If you're in the Atoridae, they still have a split part. But if you're in the Phocidae, they move as a single unit when you're in the water. Of course, another great adaptation is their hair. But hair doesn't serve the purpose for a pinniped as it does for many other mammals. So their hair adaptations here are not about necessarily keeping you warm. So the way their hair is growing is it grows in clumps, and usually that longer layer you see there is called the guard hairs. And what's happening is that the finer layers, it's all coming out of the same pore, essentially in the skin. They have a very few number of openings. So essentially there'll be one guard hair, and then they'll have the undercoat, and it will all come from the same section. And so walruses actually have very, very few hairs. And things like fur seals obviously have more, given their name of a fur seal. But what's happening is that their hair is actually more of a UV protection. It's not really meant to provide any warmth. And so that's the other reason why their hairs are very, very short. They don't want warmth. They're trying to be as streamlined and swimming as efficiently as possible. But because they need that hair to still have benefit, they still need it to protect them from the sun and from the elements, so they will shed that annually, right? So think about your dog shedding. That's nothing if you compare it to how some of the different seal species shed. So once a year, they're going to haul out on land. We'll probably have to fast for this too, depending on the species and how long it takes. And for some of them, it's a bit more spread out. It might take a few weeks. Some of them, it's very, very short. And the reason they need to haul out on land to do this isn't because they need to, roll around and scratch it off. It's because of the heat. And so in order to grow that new coat of hair very, very quickly, it needs to be warm. And so being in the water sucks the heat from them too much. So they want to be on land. Think about, maybe a strange comparison, right? But think about us, think about our bodies, right? Our armpits, like your hair goes really fast because it has a high amount of blood flow through there. It's really warm. And so it's the same thing with these guys, right? They want to get on land. They want that new coat of hair to grow as fast as possible to replace the old one, so that they can get back to feeling back in the water, back to eating, feeling protected. Now, most of them, they're shedding their hair. There's another type of molting that some species go, like our friend here on the left, called catastrophic molting, where they're actually not just shedding their hair, they're shedding a layer of skin as well. So you could almost compare that to more like a snake shedding, where it's very intense and requires a huge amount of effort. But it's a very kind of very cool thing that they go through, I think. If you could just have a complete reset every year, wouldn't have to get a haircut, just away you go. And of course, the pups shed. So this is one exception. I know I said before that they don't have fur in order to stay warm. So if you're a pup, your fur is absolutely to stay warm because you're too young and you're too small and you haven't developed a layer of blubber yet. So when they're born, they very much have this amazingly thick coat that keeps them warm and insulated and traps the air. It's also why pups really don't want to get wet at an early age, because they don't have an insulation layer. So as soon as that gets wet, there's no air trap between the hair, and they're essentially devoting way more energy to staying warm than they were previously. And then what we call a pup's coat is called a lanugo. And so that traditionally, right, that's what sealers were going after. So delving back now, we talked about the outside, we're going to delve back into the inside and some of their amazing adaptations. So I always like to, I've brought up insulin on a few different topics because I think it's interesting when we think about how our bodies have adapted and we look at things that we don't, we think about the system's not quite running properly. People who are diabetics or, it seems like, oh, like, why does this work this way, right? But when you look at nature and you look at these different environments that they have developed in, you can start to understand how these different things have come through evolution and how sometimes what is bad in one scenario can be good in another. So when pups are born, they're actually born hyperglycemic. So they have a whole whack of sugar in their blood and they have very little insulin. And part of the reason they're born this way is to help them fast, right? So remember I mentioned the pup, so they are going to gain a bunch of weight from their mom, but then mom's going to leave them and they're going to be sitting on that sea ice alone and until they're ready to molt and join the water. They might have to sit there for weeks. So they need to have their metabolism prepped and ready to gain and then to essentially maintain. And so when we think about insulin, right, the purpose of it is like a key. On your cell, you plop the insulin in, and then the glucose can go into your cell. So if you don't have a lot of insulin, that means that glucose is going to stay floating throughout your system. And that's part of what's helping them maintain throughout that fasting period. Now we're finally on to my favorite adaptation of all, which is blubber. I think that blubber is hands down one of the most fun words to say, and also amazingly adapted rendition. So it's such a specialized form of fat that scientists actually have more or less stopped calling it fat. And I spent the morning trying to think of a comparison to help this make sense. And the thing I thought of today was PC computers and Mac computers. And Macs are still a computer, right? But to be honest, if you've grown up on a PC and then you go to use a Mac, it's almost like completely different. You're like, yes, this is still a computer, but the X arrow is on the other side and you do this to scroll in it. It's so completely different that you don't even feel like you're using the same thing. That is how blubber is evolved compared to other types of fat that exist. And we're gonna delve right into that. So again, molecular bio is not my favorite thing, but it's worth it. Just bear with me. This is really, really cool. So these are adipocytes. So we have them too. This is what your fat cell actually looks like, right? And so what happens is that there's the actual cell itself, and then as your body collects lipids, so lipid is the fat. So adipocyte is like the shell that holds the fat, and lipid, the yellow part, is the actual fat, right? So as your body fills it, it fills up in these cells balloon, right? They go from these little fat pancakes to big, big circles, blobs full of fat. And so in your skin, if you look in that, or under your skin, excuse me, if you look in the top right, so that's an example of aging, but it works really well for this image. So, and then in between those, holding that together, we have collagen and we have these elastic cells, or elasticin cells, excuse me. And so that's what essentially gives it structure. So blubber has way more collagen and elastin shells, and that's how come it has that very, that more like really thick jello-like structure, right? Where it has a very solid jiggle, and it's very, very strong in that regard. And so when we think about these pinnipeds being born, this is what's really cool. So they're born with a certain number of cells, and as they grow in those early years, they're A, filling the cells that they're born with, and B, creating more of these adipocyte cells. But what's happening is that once you reach adulthood, you generally don't actually lose or gain adipocytes. All they're doing is either filling or emptying, right? So when I was talking about them having those crazy weight gains, when they're, or losses, either way, right? They're losing 50% of their body weight. The cell is still there, but what's happening is that ballooning effect, filling with fat, fasting, filling with fat, fasting, losing it, right? Such a cool accordion cycle of understanding how that works. And so when we think about the fat that they're consuming, right, is that they are, they're very efficient about the fat that they consume. And so the best way to think about this is that, they're eating, remember I said they could be generalists, they could specialists. So maybe they're eating polar cod, maybe they're eating crustaceans, whatever it is. They're taking the fat in the animals that they're eating out of their prey, and think about it as a chain, right? Or right? You've got or a bunch of knots all tied together. They don't undo, they take, when you consume, and we do this too, right? But when we eat something, you consume it and you take apart part of the chain that doesn't fit into your puzzle, right? Think about it as the chains interlocked a certain way. And so our bodies, when we digest it, we undo a certain amount of the chain, but then they reincorporate that chain into their own bodies. And this is one of the ways that we're actually able to tell what different species are eating, because even though they've eaten something and then it's become part of them, there's still a signature left of whatever it was. So the old adage, you are what you eat, is very much true now more than ever, as we're coming to realize, right? And so it's part of the ways we figure out what diet is, right? Before we was just collecting scat, but now you're able to actually take a sample of their fat, break down, okay, this chain came from cod, this chain came from a lobster, etc. It's super duper cool. And another thing to keep in mind, right, so they're eating a mostly fat diet, so they only undo the chain a little bit and they fill it back up. But for you and I, like when we eat things like sugars, the chain has to get completely undone and then rebuilt. And so that's actually much more work and effort, right? So when we build an original chain, that's like fat that's harder to get rid of. But the chains that are only partially undone are those fats that are swinging back and forth. So I hope you've enjoyed the smiled swing into that. We'll leave the molecular bio alone for a little while. I think we're good now. And so, yeah, right. So this is that change that I'm talking about, right? So most adult seals, walruses will have a bit more, right? But so they're going to have that blubber layer is usually between 7-10 centimeters. So imagine anywhere from 1 to 2, 3, 4 inches, right, is what you're looking at. And that's the part that's going to sort of expand and change throughout time. And to put that into context, if you're a whale, like a bowhead whale, they're going to have more like 50 centimeters. So that's a half meter. So you're going to have, let's do my feet conversion. You're going to almost have over 1.5 foot of blubber, right? That's how much they're going to have on a normal basis if you're a whale. So it's an amazing, definitely an amazing way to keep. And so this is just the structure of it now. This is why blubber is so cool, because not only have we learned about the fat cells, but now we're going to learn all the things that they now use them for, right? So the most obvious one being heat, right? The blubber is a form of insulation. So think about if you're a marine mammal, you live in water, and in water you're losing heat 25 times as fast as if you live in air. So you need to have a very solid insulation system set up. And so the outside of the blubber has a different vascular system. And so essentially the blood vessels close and dilate so that they can conserve the heat on the inner layers of blubber working inside. How many times am I going to say blubber today, hey? Which is very, very cool. And I said blubber and fur, but I think I really more so meant this as blubber versus fur. And so these are the two main mechanisms that we know of adapting to survive in the cold, right? And so why don't they have fur, right? Why do seals, whales, why have they invested in involving blubber rather than fur? And it essentially comes down to the diving. So if you're a sea otters have the most dense fur out of anything in the whole world. It's very, very prized, very, very warm, and it traps air really, really well between the hair follicles. But sea otters don't dive very deep, right? So when you dive way deep down, think about the pressure, right? Think about as you go down, the pressure increases, and essentially, as the more pressure you get, those air pockets against the hair follicles get pushed out, and so now there's no insulation. Because really, that's what insulation is, right? You're providing a buffer so that the heat can't transfer, and that's what the air does. It means that you can't transfer heat as efficiently. And so fur is actually really unhelpful under pressure, and it's why all these marine mammals, it's why whales have essentially completely de-evolved hair. Right? They have a few bristles sometimes around their mouth, but that's essentially it, because it doesn't serve a purpose when they're diving that deep. The other super duper amazingly cool thing about blubber, which I never get over this, is the production of water. So we call this metabolic water, right? So when you and I are thirsty, we go turn on the tap and we get a drink of water, or when you're eating soup, you're replenishing your water. But another way that we are capable of making water is metabolic water. So essentially, when we break down carbs, fats, etc., one of the byproducts of that is water. Now, I'm going to give you a heads up that humans are not efficient at this. We are not good at it at all. as compared to other species. And so don't anticipate that this metabolic water will keep you hydrated. However, if you so happen to be a pinniped or a polar bear or a dog, well, specifically huskies, they are exceptional at producing metabolic water. So essentially, seals break down the fat. When they break down the lipid, they get water back at more than a 1-to-1 ratio. So what that means is in their body, they break down, let's say, a kilogram of lipids. Out of that kilogram, they're going to get 1.7 kilograms, or 1.07, excuse me, kilograms of water. So they're producing more water than they, not gonna say that they need, but they never have to drink. That's not a requirement, right? Which is great when you live in salt water, because that would only deplete you, right? And so their system is perfectly set up for this. And just to emphasize how amazingly how cool this is that even when they're nursing, they still, so think about this. You have a nursing ringed seal who will not eat for 3 weeks. So they're not eating, they're giving their fat reserves over to their pup, and they're not drinking at the same time. And even after all that, their body is still producing enough metabolic water that they're staying hydrated, on top of giving all of the liquid to their young, which I think is such a mind-blowing adaptation. And of course, another beauty of the blubber is that it streamlines their bodies. So in general, the blubber exists in a layer all throughout their entire body. I just have a picture of a dolphin here because it's a better imagery to understand, because we're coming back to that streamline, right? When we're thinking about, I was talking about drag, right? So inefficiencies. But we know that they don't develop, they don't develop the blubber equally all throughout their body. So think about it like when you put on a bulletproof vest, right? You're protecting the regions that need it more, right? So they have thicker blubber on their chest than they do on their flippers. But we know that they don't just do it for heat, because when we look at a pinniped's tail, they actually have more blubber than needs to be there for heat. And the reason why they have that is to make them more streamlined, right? So the more smooth they are, especially at the end, so they don't create those eddies and those vortices, the less effort they have to put into swimming. And so, especially when you're giving up all of this energy to live in the water, they definitely need to economize on every bit of energy they can. And last, but certainly not least, is blubber and buoyancy, right? So when they are pups, they actually have a higher buoyancy because of their fat. So they actually have a hard time sinking. They're about 40% adipocytes, so their fat cells are full. And so until they become adults, they sometimes have trouble sinking, which I think is hilarious. But once they're adults, it's something they have to factor into their buoyancy level, right? And so the blubber, when they are, healthier, they're going to have to put more effort. So that, and part of that is controlling, if you think about diving, they can control how much air is in their lungs, right? So if they're heavier, then they have to exhale more oxygen, so they can't dive as deep. So there's almost like a balance there of like what their true optimal blubber weight is. So I think I've now succeeded in saying blubber more than 50 times in 10 minutes. So I hope that you've enjoyed it as much as I have. And it has been my absolute pleasure to take you down this road with me. I really hope that you check back in on the 21st, because I've sort of given a general outline of characteristics, but I'm really excited to tell everyone about some of my favorite species. And with that, I will pass it back to you, Sunny.
Thank you so much, Kristina. That was such a fun presentation. So many fun facts and things I'd never thought of before. And that my sentiment is echoed by several of the comments that I've seen. But before we start the Q&A, I want to remind everyone that you can submit your questions via the questions field in the control panel. So please do take a minute and submit any questions you might have. So one of the things, just real quickly, that someone asked, they're very interested in going on a trip with you sometime. Can you just share with us what kind of trips you lead and what's on your schedule in the coming months?
Yeah, well, I'm so honored. That will be my absolute pleasure. So right now, I'm actually in school as well. So I'm doing my master's at the University of Victoria. So unfortunately, I'm not guiding as much as I was before. So I do polar bear trips. So right now, I will be going to Churchill this fall. I'll be there October of this year. Um, but yeah, I also love Northern Lights trips. I'm going to do a few more in Canada. So please keep tabs on that. I am super duper honored. That's a great notion. But most of my trips will be in Canada, and I love the North, so that's my main theme. And once I'm done school, I'm gonna ramp up my guiding game again. So hopefully you'll find me in a few other locations as well.
Excellent, excellent. So here's a follow-up question. Someone wanted to understand why hunters kill baby seals. Like, what are they looking
Yeah,
for?
so yeah, I'm gonna talk a bit more about this in next week on the 21st. But so essentially, seals, their fur is exceptional as far as staying warm, right? So if we look at indigenous people, let's just backtrack a little bit, right? So like the Inuit live in northern Canada, and if you look at a lot of their traditional clothing, it's built out of seal fur for the specific reason that it's like you almost can't get better than that. It's naturally waterproof, it's obscenely warm. And so that was the main driver of that industry, right? When you think about, especially the 1800s, think about before we have all these synthetic materials, right? Like if you find fur that's already has all the properties that you need, it's not like you could just go to Patagonia. So that was the original push behind it. And then of course, following that is also fashion, right? Fashion is formidable. That's what I always like to say, for better or for worse. And we can see that throughout history where several species have suffered at the hands of fashion. And so we're getting better at that, but there are still certainly a few species who are endangered because of people's preferences, even if they don't make any sense. So it's unfortunately a balance of those two things. But fashion has fallen out, so thank goodness for that. And seal hunting does still exist in certain places. It's much more regulated than it used to be. I'll just go quickly into part of the reason why seal hunting is took off or had such detrimental effects is because seal pups are essentially helpless. They can't swim yet. They are stuck on the ice. And so it's so very, very easy to go and hunt huge numbers in a short amount of time. So imagine you are a seal hunter, you have a family to feed, and all of a sudden the price goes up, right? So they would go and decimate huge numbers. So I don't approve of what happened, but I can certainly understand why people, really went for it, because all of a sudden, before something that was barely a livelihood was, able to make a huge difference in your life. So I try to not have a simple one black and white view of that.
Excellent. So this may cut into part 2 of your talk, but someone's curious about the lifespan of seals.
Yeah, so seals, we'll go into this, I'll kind of hone in species specific, but generally, depending on the species, 20, 30 years. So you could have a seal friend for forever or for most of your adult life.
Oh, that's so fun. So you've got some compliments on your the way you were able to tackle the biochemistry. So a little pat on the back there.
Oh, well, thank you. I'm not joking. I barely passed. Like I had like a 55. I think that the professor just let me go through because I was this close to getting it through. And so yeah, I never want to go back to it. But then there's cool things where I'm like, okay, we can do this.
No, you made me think it was cool. Made me want to know a little more biochemistry myself. So thank you. So that's the last question we have time for today. So I'd like to hand it back to you for any closing comments.
Yeah, well, thank you everyone for joining me. These bring me so much joy, and I'm so excited to get to share my favorite bits of nature with so many different people. It's one of the fantastic bonuses of webinars and reaching out to so many people. So I will be following up on the 21st with another one on pinnipeds. So please check back in if you have some curiosities, or if you think of things between now and then, please bring your questions. It'll be great, and I hope you all have a lovely weekend.
Well, thanks again, Kristina, for taking the time to present for us today. I'd also like to thank everyone who tuned in. Join us tomorrow for our daily dose of nature. You can check out this week's lineup, including registration links, on our website at nathab.com/webinars. We did record today's presentation, and we will have the replay available on our website soon. With that, I'll conclude the webinar. Goodbye, everybody. Have a wonderful day.